Hi there and welcome to Tech Life, a channel where I aim to review everything from selfie sticks to laptops to IDEs for coding, video editing, software for producing thumbnails, essentially anything tech related. If you are new to the channel, please consider subscribing. If you have anything that you think I should review, please let me know in the comments and I'll do my best to review that product. Welcome to part 6 of this C# beginner tutorial. In this video we're going to be taking a look at the difference between value types and reference types. C# distinguishes between two categories of data types, value and reference types. The simplest types in .NET C# are called value types. Value types are variables that can contain data directly instead of containing a reference or a pointer to a data store. Instances of value types are stored in an area of memory called a stack. C# can create, read, update and remove variables on the stack quickly and with the minimum of overhead. The main thing we need to remember about value types is when we have a variable of value type, that variable directly contains the assigned value. Value types include all the numeric data types. So all these numeric data types such as double, decimal, int, float, along with these data types. Value types also include things like bool, byte, char, and enum, along with strut. We're going to look at these in later videos, so don't worry too much about those. We might actually, I might actually show you strut later in this video when we start putting some code together. And when we assign between value type variables, the data is actually copied from one variable to the other and stored in two different locations on the stack. Even though value types represent simple values, they still function like objects. We can still call methods on them. For instance, we can quite often call the toString method on a int variable. And it's also very important to note in .NET C# all types are derived from the system.object. So in this diagram here we have a variable called I, and that is of type integer, and we're assigning 100, the value 100, to I, and in memory I will actually contain the value 100, so the memory allocated for this variable I will actually contain the value 100. Reference types contain a reference to whatever we are trying to store. Reference types are stored on the heap. So there's two different types of memory. One is called a stack, one is called a heap. And reference type variables are invariably stored on the heap. Reference types include strings, arrays, classes, and delegates. Don't worry too much about delegates. In this beginner's tutorial we won't be looking at those. So in this diagram we have a variable called s, and this variable is of type string, and we've assigned the value hello world to s. So when we look at how this is allocated, how this is stored in memory, we can see that the variable s contains the address of where hello world is actually stored on the heap. So s contains an address to where the actual data is stored, and so this actually points to a location on the heap where the actual data hello world is stored. Let's fire up Visual Studio and write some code to illustrate the difference between value types and reference types. So we're going to create a new project. That project is going to again be a console application. We're going to give it a name of, let's call it value types. value types. Click OK to that. Wait a second or two and wait for Visual Studio to create a skeleton application for us. I'm going to delete program. I'm going to do a right click on the application name, and I'm going to come down to add, and we're going to add a new item, and it's going to be of type class. We're going to call this, just to keep things simple, I'm going to call it value type. Value type. That's .cs, so we know it's a class. And now I'm going to get rid of some of these using statements because we're not going to need those. So the namespace is value types, the class is value type, and within this I'm going to create first and foremost I'm going to create the main method. That's going to be static. It's going to be void because it's not going to return anything. Capital M for main. Open and close parentheses. Open and close braces. Okay, so that's our main method. And then we're gonna put a comment in here. I'm gonna declare a variable. Of type int. So int num1 equals 12. And we've got squiggly lines because I haven't put an equal sign between the two. And that squiggly line, it doesn't matter because it's saying you have declared a variable, you haven't used it yet. And so what we're going to do here, I'm going to declare another variable, and it's going to be called num2. And this time I'm going to say num2 equals num1. So I want to assign the value contained in num1 to the variable num2, and I'm going to output to the console the values of these. So I'm going to say console.write, and I just want to display num1 for now. I'm going to put console.readKey, so the application actually stops so we can see what's going on. Okay, I'm going to run that by doing F5. F5 will build and run the program for us. Okay, so we've said console.writeLine num1, which means output the value of this variable num1 to the console, and we assigned value 12 to num1, therefore we can see that 12 is printed on the screen. Okay, let's leave a couple of lines there and type console. Oops. Come down a line, console dot write, and in fact I'm going to put write line, so otherwise they'll be just written on the same lines. And I'm going to say num2. Okay, F5. Okay, so console.writeLine num1. Num1 is 12. Console.writeLine num2. And because we're saying num2 equals num1, 12 is printed again. Cool. Okay, let's leave a couple of lines. And we're going to put comment, change the value of num2. Okay, so in order to change the value of num2, I'm just going to clean this up slightly. Okay, so in order to change the value of this variable, we're going to say num2 equals, and I'm going to assign the value 25. I'm going to assign the value 25 to num2. So here, I'm gonna copy both of these. So I'm going to reprint the values of num1 and num2 to the console after we've changed just the num2 value to 25. Let's clean this up slightly. Copy that. Just going to put a comment here. Not a comment, but I'm going to write out a comment on the console. So Control V. And here we're going to just say after num2 value has been changed, semicolon on the end, no squiggly lines, looks okay. Console.read key at the bottom, so the program stops. No, just F5 to run. Okay, so we've got 4 values printed on the screen. The first value is 12, which is the value of num1, which was expected. The second value here is 12 again. So at the top here, what we did was we said num1 is equal to 12, num2 equals to num1. So therefore, num2 is equal to 12 as well. So the first 2 values are here at 12 and 12. Then we have this comment after num2 value has been changed. Okay, so the value here, num1, remains unchanged. That's really important to note. It's still 12. Num1 was assigned, 12 was assigned to num1, so it still remains as 12. And then when we print this value, num2, because we made num2 equal to 25, the value of num2 is 25. So the main takeaway from this is num1's value is totally independent to num2. If we make a change on num2, if we change the value of num2, it has no bearing on the value that's contained within num1. It's logical when we look at value types. I'm going to show you reference types in a minute, and you'll understand why I'm laboring the point. So the following diagram is going to just quickly show what we've done in this code. Okay, so we created a variable num1 and we assigned the value 12 to num1. So the actual number 12 is saved in that memory address. And then what we did, we said num2 equals num1. So the value that is contained within num1 is assigned in another location in memory on the stack. So there's two different locations. Okay, so value type variables contain the actual values. Value type variables live on the stack. Each variable has its own memory space, two memory spaces. After that, we change the value of num2 to equal 25. So num1 still equals 12 and it's in its own memory area. But for num2, what we did was we changed the value to 25. So then when we printed out the value of num2, it was 25, but num1 was still 12. Okay, so let's move on to looking at reference types. Reference types contain a reference to whatever we are trying to store. Reference type variables are stored on the heap. Reference type variables include things like strings, arrays. Even if the arrays contain value types, the array is still a reference type variable. Also, classes are reference types and things like delegates. Don't worry too much about delegates. We won't be covering those in this series of beginners tutorials. Okay, so let's have a look at some code. If we fire up Visual Studio, I'll go into Visual Studio, we'll create another console app and we'll put some code together just to show reference type variables in action. Okay, so if we go new project, it's going to be a console application and we'll give it a name. Let's call it ref types. Ref types, okay, that's fine, we'll do okay. Visual Studio, create some folders and some files. Cool. We can delete a program file. Delete that. Okay. Right click on the project. And we can go to add and we're going to add our first class. So it's a new item, and it's a class. I'm going to call this ref type. I'm going to get rid of all of these. And this is going to be a very simple class because I want to just keep this as simple as possible, just to show the differences between value types and reference types. So the only thing this is going to do is it's literally going to have an instant variable. It's going to be a type int. It's going to be called val. That's it. That's our first class. Let's see if this builds. Yeah, we know it doesn't contain main just yet. I'm going to make this public. Public class is never assigned, and we'll deal with that in a second. Okay, so the next class that we're going to create is going to be a class that implements this class. So I'm going to create another class. I'm going to call this reference type test. And within this, I'm going to create our main method. So within this class, I'm going to create public static void capital M for main. And within this main method, we're going to put some comments in first. We're going to say I'm going to instantiate our ref type class. The way we do that, we already know how to do this because we've done it a number of times before. We're going to start with the name of the class, which is ref type. We're going to give this instance a name, so I'm just going to call it object A equals, and we're going to use the new keyword, which means that we're going to create an instance of a class, and then we're going to use the name of the class again with the parentheses. So we've created a new instance of the ref type class. And we're going to end that line with a semicolon. Okay, the next thing we're going to do is we're going to take this reference to this instance. So we're going to say object A, and then we're going to do dot val, and we're going to set a value for the int. So for this integer, we're going to set this value. I'm going to set this to 10. Come down slightly, and I'm going to output this to the console. So I'm going to say console dot write line, open and close parentheses, open and close inverted commas, object A value is, and then we're going to take the object reference A and take the value, so the actual value of that member is going to be output. End that line with a semicolon, come down slightly, and I'm going to put a console.read key as well, so the program stops. Okay, let's do a quick build, see if there's any errors. No errors, no warnings. F5 to run. And so we can see object A value is 10. So we set the value to 10 and we got the expected result 10. Excellent. So we've got the expected result. Let's make some space here. The next thing we're going to do is we're going to create another instance of this ref type class. And we can do that by starting with ref type. We give this instance a name. We're going to call it object B. And we're simply going to say it's going to be equal to object A. So this instance of ref type is equal to object A. Okay. And let's clean this up slightly. Since we've got a reference to that second object, we can access its members, and we do that by saying object B and then dot val, and I'm going to set this to 20 equals 20. Let's copy this line, make some space here, paste, and we're going to say object B value, and we're going to output the value of B. Do a quick rebuild. No errors, no warnings. F5 to run. And the output is object A value is 20 and object B value is 20 now. Okay, so both values are 20 and that seems slightly unexpected. So let's have a quick look at what we did here. We created the first instance of ref type and we called it A. And then we created a second instance and we called that object B, objb. And then we assigned object A to B. So here we weren't actually assigning the value of what was contained in A. We were copying the value of the address in memory to B. So if I can throw up a quick diagram. So when we said object B equals object A, we're actually copying the address of this value in the heap to this object, which results in both A and B pointing to the same area in memory on the heap. So initially we assign a value of 10, but straight after that we change that value to 20. So first this value is 10 and then it becomes 20, and because both of these objects point to the same memory on the heap, they are both going to return whatever is contained here. And that's why when we print out the outputs, both of these print out the value 20. So that's the difference between value types and reference types. Okay, so I'm going to wrap this video up with a quick recap of what we discussed. We said there were two categories of data types. The first one being value type, and the second one is reference type. We said that value types live on the stack and reference types live on the heap. We saw that value type variables actually contain the value of whatever we are trying to assign to them. And assigning one variable to the other actually copies the physical value from one to the other, thereby having two different independent variables. So if we make a change on the first variable, it has no bearing on what the second variable contains in terms of its value. Next, we looked at reference types, and we saw that when we have two variables, assigning one to the other results in the memory address of the first one being copied to the second one, not the actual value contained within the memory address, just the memory address, thereby resulting in both of those objects pointing to the same area in memory. So if we change the value contained within that memory, it affects both of the objects, and we saw that in this last piece of code. I hope you have found this video to have been educational. If so, please do consider liking it, maybe even consider subscribing and hitting the notification bell so you don't miss the next part. Thank you very much for watching this. Hope to see you in part 7. Thank you very much.